how we were able to use the XRP to overcome them. And we wanted to give a shout out to the Liger bots. Thank you so much for having us here today. We really appreciate it.
Okay, so we're a low resource team. We're a community team based in Franklin. We have members from over 17 different towns, which means we're very diverse. Right now our team's mainly based of juniors and sophomores.
And we have a very strong base of students who are interested in mechanical design and fabrication, but our team has historically had very low numbers of people on software and CAD teams. So that's an issue that we're trying to solve. A little background, we're the 2-year recipients of the Engineering Inspiration Award. We do a lot of outreach.
So hi, I'm Aditya. I'm one of the software leads on Alarm and the electrical lead.
And I'm Vansh. I'm one of the software leads on Alarm and also drive team coach.
And me and Vansh have been doing FRC since Charged Up, so roughly 3 years. But even before that, we've been doing FIRST in some way since first grade. FLL, Explore, Challenge, and now FRC.
Yep. Okay, so before we even get started, we want to do a little survey. You'll understand the context once you see the questions, but that's a QR code if you can scan it with your phones, and there will be 3 simple questions to respond to. Don't worry, the responses will be anonymous. For those of us who just joined us, we're doing a little survey so you can scan the QR code and answer 3 questions.
Yeah, of course, for less than 5%.
Did everyone have a chance to respond? Okay, so as you can see, most teams have this issue where they have a really small number of students who are interested in programming, and yeah, less than 5% is pretty small, seeming as programming is such a big part of the season. Now let's see. Another thing that we noticed, okay, so how are students testing their code? Simulations, how the robot replies, okay. So as we can see, a lot of these responses require a lot of investment in like software, like either through learning Advantage Scope or having the ability to run code on the actual robot, right? So that can be a challenge for teams with a low amount of hardware. And most of code is written at the shop, which is also a big problem if shop time is very valuable.
So, some background on past ways that we've tried to teach new students how to program.
Yeah. So some of the things that we tried in the past were Java workshops, FRC ladder, and the RoboCon. So in Java workshops, what we did was we taught students the pure basics of Java. such as data types, classes, loops, and what we found was teaching these Java concepts, while they were interesting to get started in programming, it didn't really translate to robotics because there was no connection to programming a robot, so it was hard to maintain engagement. The next thing we tried was FRC Ladder. FRC Ladder is a free online course where you're guided from knowing no Java to coding a full FRC bot. The issue with that we faced with FRC Ladder was that there's a high learning curve. It gets really hard really quick, but also if you don't have a lot of hardware on your team, it gets frustrating for students when they can't test their code out. And so we faced that bottleneck when we were doing FRC Ladder. And another thing we tried out was the Rami bot. It's the precursor to the XRP. It runs a stripped down version of WPI-lib. And so the issue with the Rami bot was that it was hard for students to translate their skills from coding on a Rami bot to a real FRC bot.
So some challenges that were common to all of the solutions was that a lot of possible new programmers never start at all because they feel that there's some prerequisites to programming that there aren't. They think that they need to be really, really smart, or they need to be really, really good at math, where really programming is just a skill that you need to learn and work at. And so we also found that keeping new members motivated is really tough because when shop time is limited and they're only writing code in the shop and only able to test code in the shop, then they have a lot of trouble keeping practicing and keeping working on their skills.
Okay, so.
And so the solution that we found to this was the XRP robot, which was released roughly 2 seasons ago. So the XRP robot runs full WPI-lib, which means that it's no watered down code and it directly translates over to real robot programming. And the XRP is also very easy to use, and it has a very low barrier to entry, which means that students get the instant feeling that they did something and that they can program, and that's really important so that they keep programming. And the XRP is also affordable to FRC teams, and we'll go over how we made it more affordable. And the XRPs, most importantly, allow students to work at home, and every student can have one, which means that they can keep learning.
Some of the ways we were able to reduce costs, so if you buy the XRPs with your first ID, you get a $25 discount per robot, which is pretty significant if you're buying a lot of robots. And then if you have a 3D printer, you can actually 3D print the chassis. It's a great way for teams to use leftover rolls of filament from the season. And if you don't have a 3D printer, you can always buy the chassis, but it's a great way to save on costs. And then you get free shipping if you buy them in bulk, so that's great also. And through these methods, we were able to bring our costs down to $75 a robot, which is not cheap, but it's also relatively inexpensive compared to a RoboRio.
And so this is how we ran the program. We ran it in 6 weeks with a progressive curriculum. We started small, just having them run basic code and move the robot around, and we moved up more and more in complexity. We taught them PID loops and a bunch of other things. Me and Vansh taught them all the way through the process, including online meetings on Zoom in between the in-person classes, so that they could ask questions about their homework and keep learning. And we encouraged collaborative projects and challenges for teamwork.
We wanted to make sure that our curriculum was in-depth so that students actually understood what they were coding, and then when they moved on to the real FRC bot, they were able to translate their skills. So to start off, we did an introduction to Java and object-oriented programming. Our software mentors, Coach Steven and Coach Gabby, did a deep dive into the basics so that when students started our 6-week course, they weren't feeling lost. And then we taught them command-based programming because we realized that it's a different structure from a timed robot, and students can sometimes get confused when transferring between the two. So we just directly taught them command-based structure. And we did a lot of sensor integration and PID control. So the XRP has a distance sensor and a gyro sensor. And using the data that you collect from them, you can tune PID loops to make smarter robot motion. And that was really helpful to teach on the XRP because it's kind of hard to do it on a real FRC robot. And so getting experience working with PID loops on hands-on is a lot better than on the FRC bot. Students get practice from beforehand. And then we also taught FRC tools such as Elastic for posting data and Advantage Scope for simulating robot. It was really helpful to do it on an XRP because students could do it individually one-on-one and test their code and see a result. And then one more thing that we have, if you scan the QR code over there, we created a live GitHub curriculum of the 6 lessons that we did. So. So we created a 6-week curriculum so that any team can do the same things that we did. So we go over, prerequisites, different things to focus on when teaching this lesson, the different tools, and then it's a step-by-step guide so even students could follow this. And that's really helpful because we have noticed that in between years, like if we don't document things, knowledge gets lost. And so having a complete documentation of our process ensures that we can do this year after year. And then we've included code snippets that students can create themselves, edit, and run on their bot. And we've done this for all 6 lessons. So Aditya now is going to show you how students progressed with their code. So we're going to do a week-by-week demonstration.
Okay. So the first week, they just learned how to set up the robot and how to move forward and backwards and create a simple drive forward command. We'll go over that. Okay. So we first teach them how to move forwards and backwards, and how to create a drive Just create a drive forward command, and then we teach them how to use the arm. We taught them how to use the distance sensor to create a stop and wall command. And so it uses the range map. Okay, that's good.
We will talk about the issues we also face. Yeah, that's one of them.
Okay. And then we use the distance sensor, and you saw one accident. We taught them how to create a PID loop and use feed forwards to create a gyro turn. And we ended it off with a session teaching them simulation in Advantage Scope.
Okay, so now we can talk about the findings we had. So the good part, we were able to retain a significant amount of students, 4 out of 12. Well, that's only sounds like 33%. That's a lot better than our past attempts. So we were able to double our software team size, and we had a lot of student engagement, people coming repeat after repeat on the classes and doing the different functions and classes that we made. It was cost effective, it wasn't a financial strain on families, and students, very importantly, were able to test what they learned at the shop at home.
And so we saw a couple of the bets there. So one of the issues that we faced was that the motors have very high friction and they're not super powerful. They're not as current controlled as we would have liked them to be, which means that if the batteries are a little lower charged than like say 80%, they really take a lot to get started. And that just meant that we had to have really high feed forwards, for example, gyro turn. Also, if the robot is moved while it starts, the gyro will drift, which will cause a bunch of issues. As you just saw here. When there's a lot of Wi-Fi networks in the area, if you don't have the XRP set up in access point mode, which connects to the Wi-Fi, then there will be connection issues a lot of the time. And so the way to solve that is by setting up a special mode where it connects through the Wi-Fi.
And even on the Wi-Fi network, when we had a lot of students testing their XRPs, we had some students with like different computers, they would have network packet drops, and so like they would be moving their joysticks and nothing would happen on their XRP. So a solution that we were looking at was buying a modem specifically for XRPs. We're still testing if that works, but that was our initial solution to the problem. And then another issue, the XRPs were pretty popular, so they were back ordered. We had to shorten our thing from 8 weeks to 6 weeks. And then another thing was that like we did Zoom meetings, and we found that those didn't really work because we got low participation on those. So we kind of switched to the in-person meetings, which work a lot better. And here's a quick video summary.
On the top, we have the circuit board, and on the front, we have a distance sensor, and then you can mount the servo wherever. It's like flips on and off. And then underneath, we have the line following sensor, the battery pack, and then we have the two motors, and then the wheels, and we have the casters over here. To drive it, it's frontwards, forward and back, turns on and off. And then B, it goes like farther, and then A, it just goes a short distance. So yeah.
As you can see, there's less lag.
In less Wi-Fi interface, so.
Yes, there's a member of the class. That's the notation that we usually use for saying that it's a member of the class. So we're importing the drop.
Yeah, 0 to 36. Massive, right? So, and because our need to what's the that's a lot of the time, right? That though is hard to fix, which is why we not want
See that we're getting oscillation. So as you can see, you can have a lot of fun with XRPs. Once you get started, it's great. Okay, does anyone have any questions for us? Yes.
That last bit, was that like an autonomous thing, or was somebody?
Someone
driving that?
Someone's controlling.
Okay.
Did you create any autonomous routines or?
We did make a couple autonomous routines with the rangefinder. What we did find though is that the XRP isn't really consistent enough to do any advanced autonomous stuff.
Yeah.
Do you find that it's helpful just for like teaching people how to program, or is it also helpful for like prototyping during the season?
We're not super sure about prototyping. We haven't really hit that yet. What we really found it was helpful for was teaching them how to debug programming, because during normal programming teaching, a lot of what students learn is like mentor driven. There's someone looking over their shoulder saying, okay, here's why that wouldn't work. But we found it was often a lot more helpful for students to see that wouldn't work and see what would happen, why it might.
And also, like, the issues that we had on the XRP are really similar to some of the issues you might see on a real FRC robot. Like, you know, when you're PID tuning in, you're just oscillating, right? It's really good to put it into perspective of, you know, these are the same skills you'll use on a real robot. Yeah?
When you shortened your program from 8 to 6 weeks, is there anything that you either cut out in those 2 weeks, or did you just expedite your teaching?
We did expedite our teaching a little bit with the Saturday meetings. We would teach a little something during the Saturday meeting, and then we'd go over it during class really quick so that they could test it in shop. And so that expedited our teaching a little bit.
Yeah.
What is the kind of tooling environment? Is it used similar driver station? Does it work with a simulator? Like, you know, can a student who might be doesn't have their XRP with them, could they still test their code in the sim? And kind of how does that story work?
I don't think they can test their XRP in the sim, but it does run off the simulation interface. So rather than running it through driver station, you use the same start simulation and it just connects to the XRP.
So you said you started out with 12 students. You had 12 XRPs?
Yes.
Cool. And so you 3D printed the chassis. Do you buy all the other components individually then? Or is there like an extra?
They sell a kit without the chassis because they know a lot of first teams have 3D printers.
But it comes with all the extra.
Okay, and is that kit also typically backward?
Yes.
Okay.
Did you buy through SparkFun, or is it another vendor?
I think we bought through a couple different vendors whenever we could find stock.
Okay.
Spark Fund means the
So in terms of consistency, I mean, I played with the Romy a bunch of years ago. Is it actually more consistent than a different environment, I understand, but is it sort of very similar in terms of mechanically operating like the Romy? You think?
From when I played around with the Rami, the XRP definitely actually seems more consistent, especially in the shop space. I wouldn't necessarily say it's better, just that it's more consistent with what it does.
Okay.
And the batteries are rechargeable?
Yeah, it runs off AA, so if you get rechargeable AA's,